From this video lecture, we will look into now the types of organic reactions, right? Which, as I have written, is substitution, addition, elimination, rearrangement. So in this video lecture, we will look into the details of nucleophilic substitution reactions and its types, right? But before we go into that, let's look into what we did before, right? And what we would be doing from now onwards, from this lecture onwards. Before this video lecture, we understood that an organic reaction is actually a reaction between a substrate molecule, right, and a reagent, right? And we know that substrate is an organic molecule, right, that would be attacked by a reagent, right? This reagent, which can be an electrophile, right, or a nucleophile, right, that means positive or negative, right, will attack this substrate molecule, right? Before this video lecture, we were going through different types of reagents, nucleophilic and electrophilic, right? And before that, we have looked into our reaction intermediates, right? When reagent will attack a substrate molecule, this substrate molecule, before forming product, it will go through a reaction intermediate, right? It will become a reaction intermediate which is of high energy, right? And it immediately reacts with the surrounding atoms or groups of atoms, which can be an electrophile or a nucleophile, right? So when reagent will attack it, it will form a reaction intermediate, right? It will form a reaction intermediate, and this reaction intermediate are your carbocations, right, which are like this positive carbon ions. They can be carbon ions which are negative, which have a negative carbon, right? And then you have the third type of intermediates as free radicals, right, that have an odd electron, that have a single electron. For example, chlorination. In the presence of sunlight, it will form free radicals, right? Now these free radicals are highly reactive because they will react in order to pair up their single electron, right? And these are again carbon ions and carboanions and carbocations. Both these are reactive intermediates. These are also reactive, and the carbocation, which has a positive carbon, would be attacked by nucleophilic reagents, right? Now, and this carbon ions, these would be attacked by electrophilic reagent, right? Now when nucleophile will attack this positive carbon, right, it will replace it, or it will replace the already present electrophile at the which is connected to the carbon, right? So, and in case of electrophilic reagent, when this electrophile will attack this negative carbon center, it will replace the already existing electrophile, right? So basically, the attacking nucleophile would be a strong nucleophile, and which will replace your weak nucleophile, right? So this would be the attacking would be a strong nucleophile, and here the nucleophile that would be present here would be a weak nucleophile. Similarly here, the electrophile present here would be a weak electrophile, right? And the attacking electrophile would be a strong electrophile. Now and similarly here, these free radicals would be attacking the organic molecules, right, and will result into products. So the reactions basically substitution reactions are those reactions. In this video lecture, first we will go through substitution reactions, right? Substitution reactions. So substitution reactions are those reactions where one atom or a group of atoms would be replaced by other atoms or groups of atoms, right? When the atom or group of atoms would be replaced by a nucleophile, would be attacked and replaced by a nucleophile, we call it a nucleophilic substitution. We call it a nucleophilic substitution. And when the atoms or groups of atoms in an organic compound would be replaced by electrophilic reagent like this, right? We call it a electrophilic substitution reactions, right? And similarly, when the organic molecule would be attacked by free radicals, right, we call it a free radical substitution. Free radical substitution, right? So these three substitution reactions we would be going through in this video, in coming video lectures. In this video lecture, we will look into nucleophilic substitution reactions. So in nucleophilic substitution reactions, what happens is the attacking reagent would be a nucleophile, right? And it would be a stronger nucleophile, like I explained here. This stronger nucleophile would attack the positive carbon, right, and will result into the replacement of a weak nucleophile. So a strong nucleophile would be replaced by, a weak nucleophile would be replaced by a strong nucleophile in nucleophilic substitution reactions, right? So basically in nucleophilic substitution reactions here, strong nucleophile will replace weak nucleophile. Right? For example, if you have a tertiary halide, right, when it is attacked by a nucleophilic reagent, hydroxyl ion, we know that it is a nucleophilic reagent. It has a lone pair of electrons. The oxygen atom of this nucleophile has lone pair of electrons, right? Now this tertiary halide will ionize, right, and will form a carbon ion. It's a carbocation. It will form a positive carbocation. We also call it as carbonium ion, right, and Cl minus, a chloride. We know that this is negative, right? So this is your weak nucleophile here, right? And this attacking nucleophile, this is a strong nucleophile, right? Now this strong nucleophile will attack it and replace this weak nucleophile, right, resulting into the formation of product, right? Now depending on the order of reaction, right, these types of nucleophilic substitution reactions are divided into SN1 and SN2, right? First thing is that we call this nucleophilic substitution reactions, nucleophilic substitution. These are designated as SN, substitution nucleophile. That is, substitution by a nucleophile are SN reactions, right? Now depending on if the reaction, this type of a reaction, if the order of reaction is 1, right, then it is your SN1 reaction, right? And if the order of reaction is 2, it is your SN2 reaction, right? So these substitution reactions are SN1 and SN2 reactions depending on the type, depending on whether the reaction is of first order or second order. That is, whether the reaction depends on By first order and second order we mean whether the reaction depends on the concentration of single substrate or single reactant or both the reactants, right? For example, in this reaction we have OH ion, right, which may be from NaOH. Whether the reaction depends on this halide ion only or on halide ion and sodium hydroxide, right? If it depends only on halide ion, then it's a first order reaction, right? Because rate of reaction in SN1, rate of reaction depends only on substrate, right? Substrate here is your tertiary alkyl halide, right? If it depends only on substrate, then it is an SN1 reaction, and here the order is 1. Similarly, if this reaction, right, if the substitution reaction depends on the concentration of your both the reactants, that is the substrate and the reagent, then it's your SN2 reaction. Since it depends on both the concentration of both reagent and your substrate, it is your second order reaction, right? This is from chemical kinetics, physical chemistry. You should know about order of reactions, right? So if your order of reaction depends on, let's use this bracket, if it depends on your substrate, right, as well as your reagent, then this is your SN1 reaction and the order of reaction is 2. Just remember from physical chemistry that reactions that depend on the concentration of both the reactants or two reactants is second order reaction, and that depends on the concentration of single reactant, it's a first order reaction, right? So SN1 reaction and this order of reaction, when we say rate of reaction depends on the concentration of substrate only, it means that we have this reaction is a two-step reaction, and the overall rate of reaction depends on your one of the steps, one of the two steps, right? We'll just look into it. And this type of reactions, in these types of reactions where the rate of reaction depends on both the reactants, the substrate and the reagent, these are single step reactions, right? Where attack by reagent and the dissociation of already present nucleophile takes place in a single step. We'll just understand that in a moment, right, in detail. So SN1 reactions, basically all tertiary halides will undergo SN1 reactions, right? For example, this is your tertiary halide, right? This is your tertiary halide, right? A haloalkane. In the presence of sodium hydroxide will give you OH, right? And it will form tertiary butanol, right? Now this reaction takes place in two steps. In first step, this will undergo ionization, right? This tertiary halide will ionize and it will form this, right? Now this is a slow step reaction, right? Like I said, this reaction takes place in two steps, right? And this first step is a slow step, right? Which is your ionization of your alkyl halide, tertiary alkyl halide, to form this intermediate carbonium ion. This is your intermediate carbonium ion, right? So if formation of intermediate carbonium ion, this is a slow step reaction. And it is on the rate of reaction depends on the slow step reaction. Why? Suppose we have in total, suppose we have 1, 2 steps, 3 steps say, right? And reaction is considered complete when all the 3 steps are complete, right? Suppose this is the first step is the slowest steps, like in this case. First step is the slowest step and these 2 steps are fast, right? So when actually a reaction is taking place, this will complete first, say, and this will say these 2 will complete nearly in the same time, right? But still the reaction is not considered complete because first step is not complete. Like say first step is the ionization of this halide. Since first step is not complete, so the reaction or the rate of reaction will depend on the completion of this slow reaction. This is your fast, this is your fast, this is your slow step. So rate of reaction actually depends on the completion of this first step, right? So this rate of reaction depends on the concentration of your alkyl halide, right? On the concentration of alkyl halide. This is what we mean in this when we write that rate of reaction depends on substrate only. Actually it depends on the ionization of substrate, and ionization of this substrate is your slow step reaction, right? And when this slowest step will complete, right, then only the reaction is considered as complete, right? So the overall rate of reaction, that's why we say, because it doesn't matter if second and third steps gets completed up quickly, right? But if the first step is not completed, the reaction is not considered as complete, right? Or we say that the overall rate or the reaction depends on the first step, right, which is your ionization of your halide ion, right? So when this step is completed, then only the reaction is considered as complete, right? This is what we mean when we say that this is a slow step reaction, and it is on slow step reaction that the rate of reaction depends, right? Because when the slow step is completed, then only the reaction is considered as completed, right? So this is your slow step reaction in SN1 reactions, right? Now this is a carbonium ion, right? This is a reaction intermediate, right? Reaction intermediate means it has higher energy. Its energy is on higher side. So since its energy is on higher side, it will immediately react with whatever it has in its surrounding, right? And what we have is your sodium hydroxide reagent that provides you with your OH ions. Let's write it. So second step would be a fast step, right? It would be a fast step where your nucleophile will attack the carbon of the carbonium ion, right? It will attack the carbon of the carbonium ion, and since it has 2 lone pair of electrons, right, and this carbonium ion, right, this is, since it has a positive center, right, which is deficient in electron, right, this is deficient in electrons, right? So when OH will attack, OH is a nucleophile, when OH will attack this positive center which is deficient of electrons, this OH, the oxygen atom, will provide or donate its lone pair of electrons, right, this lone pair of electrons, and will form bond with the carbon atom of the carbonium ion, right? So here, since this is deficient of electron, this is your electrophile, electron loving. Electrophile means electron loving, so it loves these electrons and will accept it, right? Similarly, this has a lone pair, right? Since it has a lone pair and it is your nucleophile which is negatively charged, from previous discussion we know that nucleophiles are positively charged and they have lone pair of electrons to donate, right, in the course of reaction. So a reaction, you can see it's a reaction between an electrophile and a nucleophile, right? This is what we need to understand here, right? And this is your first step, ionization of this halide. This is your second step, which is a fast step, right? So first step is your slow step, the second step, this is your fast step, right? And on fast step the rate of reaction doesn't depend based on this explanation, right? Because the overall rate depends on when the reaction will complete, or the rate of reaction depends on the completion of slowest step, which is in our case is the ionization of tertiary halide, right? That is why we say rate of reaction depends only on substrate molecule, which is this, right? And it does not depend on your reagent, because the attack by reagent is a fast step reaction, right? So what it will form is, right, OH. So this is your nucleophilic substitution reaction, where a weak nucleophile, which is in our case Cl, chloride ion, this is a weak nucleophile, right, is replaced by a strong nucleophile, right? This is your strong nucleophile, right? I hope this is clear. Now let's quickly look into the stereochemistry of this reaction, right? When we say stereochemistry means how these nucleophiles and electrophiles are reacting in space. If we look, or if we study this reaction in 3 dimensions, when we say 3 dimensions, attack from different sides, right? How this OH is attacking this carbonium ion reaction intermediate, right? From which side it is attacking, right? And why not from some other side? This is your stereochemistry. Stereo means space, so this is your space chemistry, chemical reactions in 3-dimensional space. This is what it means, right? Now when we study stereochemistry, basically we would be looking into the geometry of organic molecules, right? Now if we talk about the geometry of this carbonium ion is basically, this carbonium ion is a planar molecule. Since this is a carbocation, if you just look at the previous video lecture, carbocations are planar molecules, right? So this is a planar molecule, right? This molecule is a planar molecule, right? Now since this is a planar molecule, right, let's say it is like this. This is a planar molecule, right? And a planar molecule can be attacked from any side, right? Yeah, so planar molecule would be attacked from any side, and it is basically a tertiary halide. If you look at this, right, this is a tertiary halide which will undergo an SN1 reaction, right? So you need to remember one thing, that the tertiary halides will undergo SN1 reactions, right? So like I said, when this tertiary halide will ionize, it will form this carbocation. Now this carbocation, this is your carbocation, which is your planar molecule. It's a plane molecule, right? So it can be attacked by this OH ion from either side, right? It can be attacked from here, right? This OH ion, say this is your OH ion, right? This OH ion can attack it from this side as well as from this side, right? So what it will result into is this kind of a molecule. Since it can attack from either side, it can attack from this side to form this product. Sorry, let's take it here, right? And it can attack from this side also. It can attack from this side to form this product, and it can attack from this side, right, to form this product. You can see the geometry of these two products are different, right? And these two are mirror images. If you remember isomerism, these are mirror images, and we call these as enantiomers, right? We call these molecules as your enantiomers, right? So these are enantiomers, and what results is your racemic mixture. This is a racemic mixture, but it is not exactly a racemic mixture, because if you remember, racemic mixture consists of equal quantities of both these enantiomers, but sometimes one of them is more than the other. So this is not exactly a racemic mixture, right? So I'll repeat once more time, just looking into its stereochemistry, that this tertiary halide will ionize, it will form a carbocation. Carbocation is planar, right? So this planar carbocation can be attacked from either side, from this side or from this side. If it will attack from this side, this reagent will attack from this side, it will result into this product. If it will attack from this side, it will result into this product. So product of the reaction would be a racemic mixture, but not exactly racemic mixture, because racemic mixture means 50% this, 50% this. So sometimes one of them may be more than the other, right? So this is your SN1 reaction, right? Remember the geometry of carbocation here. Now let's look into SN2 reaction. SN2 reaction is a single step reaction, right? And mainly SN1 reactions are undergone by tertiary halides. Tertiary halides. Tertiary halides are those where your halide ion is bonded to a tertiary carbon atom, and tertiary carbon atom is where this carbon atom is connected to 3 other carbon atoms directly, right? Now if we talk about SN2 reactions, SN2 reactions, these are single step reactions, and the rate of reaction depends on the concentration of substrate as well as the concentration of your reagent, right? Reagent here is your OH ion, right? So similarly, like here, ionization will take place. It will form a carbonium ion, right? It will not ionize this way since it's a single step reaction. So what will happen is, on this carbon ion, right, on this tertiary halide, this OH ion will attack, right, and it will result into a transition state, right? This is your transition state, right? In this transition state, your already present nucleophile would be leaving this carbon atom, and your attacking nucleophile, which is OH, would be getting bonded to this carbon atom, right? So here your both leaving nucleophile and attacking nucleophile would be bonded to the carbon atom, right? But since one of them will reside on it, right, and we know that this OH ion is a strong nucleophile, right? So the oxygen atom, right, will pull the electron pair towards itself, right, forming bond with the carbon atom, and since this is a weak nucleophile, it will lose it and will depart, or would be replaced by the OH ion. So what it will result into? This. Right, it will result into this, right? Now in the next video lecture we will look into stereochemistry of SN2 reaction. What is Walden inversion and stereochemistry of this reaction.